Now that I've taken the main board out, I'm really glad that I did, because I found some other issues. One, after I undid all the wires and the stakes, it wasn't lifting up on this side. And it turns out it's because this dual control that sticks up here was bumping into terminals on the width control. And I don't remember having that trouble on other sets, so I went over and looked at my reference, and the terminals for the width control are pointing up. There should also be a piece of insulating board here. That insulator is missing from this, and this had the leads pointing straight down, and they were virtually making contact with the top of this, which is not a good situation. It looks like the right control, though. I think this is the original, but I looked at all these other chassis, and they all have the width control with the lugs pointing up and an insulating wafer. This one was pointing down. I couldn't quite tell. It looked like this is held on by a couple metal tabs that go through these slots and they get twisted around. There were some slight marks, but I could not conclusively say whether or not it was definitely unmounted and remounted. All I know is it doesn't match any of the other ones I've got. The other issue is a bit more significant potentially. Several of the tube sockets have been changed out, which isn't necessarily a bad thing because they're not necessarily the greatest quality. Now, all of these we've looked at so far, the sockets have been fine. There's a lot of them still have the original tubes in them, so what happens is from tubes getting taken in and out, stress cracks can form in these lugs. Okay, fine, they got replaced. However, whoever did this must have had trouble sourcing originals, I'm guessing. But they are available surplus that match the originals exactly. The problem is this one was replaced with a socket that doesn't have a shield around it. It's supposed to. It's supposed to be like that, guys. And no, it's not. The styling is different. They are not quite the same. I think it doesn't really matter as long as they fit board nicely. It looks like this one's a little ugly though. Looks like it had leads coming out around the bottom and they were folded and twisted and manipulated to go into the holes. That one is the correct type, although it's a different color and that matters. But the shield is gone. Huh. Well, I'll see what I have. I'm kind of wondering, because that socket looks like it's right, so why didn't whoever worked on this just transfer the shield from the old socket to the new one? What's the telescoping one too? Don't know if I have any spares. Surplus Sales at Nebraska has these sockets. They have a huge inventory of the 9-pin, and they not only fit perfectly, now this exactly the same style as the originals, but they have thicker gauge metal, so they will hold up a lot better. And I have 7s that have shields, but that's a 9 with a shield, and it's a telescoping one. So, it's a Sigi 7 horizontal output tube. I presume that was fairly important. It's kind of a sensitive circuit. I assume it's fairly important to have that shield, so we'll definitely do what we can to replace it. Here's one more issue. The sound detector should be a 6CS6 tube. We had a 6BE6. They're related. One is a sharp cutoff pentode, the other is a remote cutoff pentode, I do believe. They're similar, but they're not interchangeable. Not in every application, anyways. Video out should be a 6AW8. We had a 6BA8, which is listed as a substitute, but not a preferred substitute. So, we'll be replacing those with the correct tube designation. Turns out that two of the sockets are missing their shields. I just removed this one, and luckily I went through my stash of scavenged parts, and I do have the exact shield that is supposed to go there. So, one down. And now for the actual socket, that's a 7-pinner. I think the only 7-pin ones I have are phenolic, but they line up with the holes perfectly. Like so. Whereas the original was a plastic version of this. The only places I've seen that sell them have a built-in shield. So if I didn't have that one, I could have plunked this guy down. What I'm still looking for is a telescoping shield for the 9-pin variety. I do have another one of these, and if I had to, maybe I could make it work. I don't know. It's cool if somebody found brown ones, though. I've never seen that. The ones that Surplus Sales sells are mottled black and kind of orangish. But notice how thick the metal is on those. And here's an original. It's like half the width. And here's the Surplus Sales in Nebraska flavor. Again, much thicker metal. But if they look fine, and I've just been letting them go. You know. Oh yeah, the final thing. Replacing the tube sockets is stressful to the circuit board. So here's the one that they did that I just removed the solder from, and some of the traces have lifted up. It's much worse in other areas. Pretty much every couplate that got replaced, traces lifted up. And in one case, they put a wire. I guess because so much of the trace or pad was destroyed. Here's seeing some other examples. Well, that's really bad. I haven't had any issue whatsoever with traces lifting. Now I do have a temperature controlled soldering iron. Around 660 works great, and I work quickly. So it's kind of a shame. It's tough to reattach them. If you use any kind of adhesive, when you solder it, it heats up the adhesive, makes a horrible odor, and probably breaks the seal, and you can't really glue it after the fact too well. When these were made, it was done with tons of pressure, or so I've read, to kind of fuse the copper to the board. Trace is almost broken off there. Now you might be wondering, Bob, why don't you just take one of those nice 7-pin sockets with the built-in shield and plunk that down and you're done? It's not that simple. Notice these sockets all have a metal collar going down the center. If we flip it over, they're crimped, holds the socket in place. Some of them are grounded, some are not. This 7-pin socket, there it is not going to anything. It's not connected. Well, if we look at this guy, that shield is connected to the center post. So this would work fine if it was an arrangement where that center post was grounded and going to a grounded shield. That's not the case here. Probably wouldn't do any harm if I grounded this underneath the board, but I don't want to take that chance. What am I talking about? Well, having a grounded piece of metal in between all these pins will add some capacitance, very small, and might interact with something in a way that is undesirable, so I don't want to mess with it. So I simply took one of these and popped the shield off, which leaves us with this. And this we can plunk down, and then we'll take our shield and put it over the top of that. And the shield goes to two holes that are grounded underneath. Now let's turn our attention to the chassis for a bit. We've been focusing so much on that main board. Well, there is other stuff we need to do. Amazing how clean this chassis is underneath, considering how dirty it is up top. I did brush some more of the dirt and debris off, which helped, but what I want to do now is take the cover off the IF board. It's quite corroded, and you guys can see what's actually in there. To do that, there are some twist tabs on the back I need to undo. 1, 2, 3, 4, 5, 6, I think. Also, with that out of the way, it makes it easier to work on the power supply behind it. I used a pair of pliers to straighten out the tabs on the shield underneath, and then I had to bend that back a little bit, hooks around the input cable, and then it lifts right out, revealing a second circuit board. This one's a bit different though. There are no paper caps that need to be replaced. Some carbon comp resistors that we can check, or just replace all of them. The rest are ceramic caps and coils, which I've never had to do anything with. One thing kind of interesting is that these three are core slug adjustable coils, transformers. These are adjustable capacitors for the input network here too, and this is the IF amp and the detector. And then it goes off to the main board where we have the video amp. Now, because this set is so dirty, I really want to get back in here and rework this power supply, clean the corrosion off these fusible resistor terminals. So I'm going to go ahead and pull this board out, which isn't all that difficult because there aren't that many connections. 1, 2, 3. Then a fourth and a fifth on the back, more corrosion. One more over there. We have a few grounding stakes. This we can leave connected because it unplugged from the tuner, so it's fine to just leave it. And then we can clean all this gunk out, and then we get really easy access to all this stuff. That's the main reason. Even if I wasn't going to do anything to this board, I'd be inclined. You can leave most of the wires attached, I think, but at least undo the grounding stakes and fold it back so you can really get in and work on that terminal strip, because that's where we want to mount our... Here's a set I was restoring 2 years ago. This I thought I had derusted. Well, I know I did, but I see it's got some corrosion spots that came back, so that's going to go in the Evaporust bath along with this shield I just removed. Now here's what a reworked power supply looks like after I'm done with it anyways. The two main caps for the voltage doubler on the B plus go here, and there are the two big beefy 3 amp diodes I used, 1N5408s. They're overkill, but they just cost pennies, so why not? And here's what the board looks like after it's been reworked. I noticed there is one cap here. That, I believe, normally is on this terminal strip, but I relocated it here because this is what it's actually doing. It's filtering voltage on this point, and then the other leg gets grounded. With the older parts being larger, they couldn't have fit it in here. It makes a lot more sense to put here, so that's what I did. Here's my little Evaporust station going on in the utility sink. For those who don't know, this is a really nice rust remover. No acid, no caustic components. You may have heard that molasses can remove rust. This works in a similar way. It's kind of a type of sugar. It's a large molecule that gloms onto the iron oxide apparently, and takes care of it. It's a little expensive, but totally environmentally safe. You can just pour this down the drain. That's not going to hurt your skin. I don't recommend drinking it, but I don't think it would kill you, at least not right away. So I've got part of an Admiral TV in there now. I'm just going to add in this guy and add in this guy. We'll let them sit for a few hours and then check on it. Agitate it occasionally. A little container like this, I think, is 15, 20 bucks, something like that. It comes out yellowy like that. It'll get darker as it gets used up, but you can keep reusing it and reusing it until it just stops working. Next up, let's take the high voltage box off. So this far in, I think this is actually going to be the first chassis that's going to get powered up after being rebuilt. Now you may be thinking, you've never seen one of these flybacks before. Oh, that looks terrible, it's all deteriorated, it needs to get replaced. No, that's perfectly normal, and not just for a Predicta. It's typical of flybacks of this era. They're coated with a wax. Over time, the wax cracks, melts, drips. There's a drip or two down below. No big deal. Looks like somebody dabbed on some high voltage sealant, which is my recommendation. Either leave it alone or use some kind of Corona dope or red varnish. Those are products made specifically to seal high voltage. One thing that I'm going to do here is what I was warning about. When you take the high voltage lead cap off the high voltage regulator, rectifier, jeez, can't talk today. Alright, let's just recreate how this was. So, when I was reaching inside that box, I wanted to take this off so I could pull the tube out. You don't want to just put a lot of strain on that because you can break it right off this donut. There are many, 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 many windings of very fine wire inside this donut, and the primary is inside the inner winding. This is a huge step-up transformer. This is when the high voltage comes out here, gets rectified, and the rectified high voltage comes out at the base. So carefully lift it up, but even so, notice it's cracked. It's probably cracked before I lifted it. We can reflow that. This is wax. We can use a heat gun or soldering iron and get it on there, and it will help strengthen that joint up. Otherwise, again, we can use Corona dope. That, I suspect, is red varnish because of the color, which is another high voltage sealing product. Works perfectly fine. Corona dope is clear, dries very fast. It's similar to like a thick lacquer. Red varnish is a little bit different. It's more like Rust-Oleum, rusty metal primer. It's kind of a thick red paint kind of substance. Less expensive, less volatile. Corona dope is expensive. Comes in a little bottle. The solvents are pretty potent. On the plus side, it does a very nice job of sealing high voltage, and it dries very quickly. Here's the final result. It actually worked faster than I thought it would, considering it's a little chilly down here. It's probably in the mid-50s, but I guess when the stuff is fresh, it works quite well. Took about maybe an hour to completely treat that, and high voltage box turned out nice as well. To keep the corrosion from coming back, I spread a little T9 on it, liquid wax, basically. And it was developed exactly for this purpose. So I've found it works quite well, and also keeping this set in a dry environment will help considerably over the long run as well. Finished redoing the IF board. Basically done with the main board. I think I got one more coupling to install. I was torn about replacing stuff, but I found some resistors they had been replaced and they used a different value. Like hiding underneath this cap is a 1.8 meg resistor. I found a 2.7 meg resistor. There's no run revision or recommended change for that component. That should be 1.8 megs, so that's what I put in there. I was able to scrounge up a selenium dual diode socket, so I replaced the one that had been removed. The only thing left to do, aside from installing this guy right there, is I still need to dig up a shield for that tube. Also noticed that on these two modular pots back here, this one is partially broken off. It still turns. It's not an adjustment you make too often, so I think we'll be okay. Just something I noted. This set just has so many weird little odd problems, or things that are missing or things that are damaged. All that being said, I wasn't planning on this being the first one to get fully restored, but since I tore it apart so much, we might as well. So next up, I'm going to clean up in this area a little bit, and we're going to rebuild that power supply. While I had this board out, I also cleaned up down here with some CLR. I'll get in here a bit, but I'm not going to remove all this wiring. But I'll just use some Q-tips and clean it up a bit, and I'll also replace that with something a little more appropriate. If you're wondering what that resistor and capacitor are all about, they're here. There's one that goes across the line, and then one that goes from one side of the line to the chassis, so that's the 470K. And that value I don't think is super critical, but you want to use a type X capacitor rated for across the line duty. I've been using 0.01s because they make a nice ceramic one that's relatively inexpensive. It works in both X and Y applications, and I think that will be just fine. I finished rebuilding the power supply. The IF board has been installed with the shield temporarily in place. I won't firmly affix it until the set's working. I replaced that completely fried power resistor. It did measure open. I put in the last two electrolytics here. Finished cleaning the metal surface underneath where this board goes, and I installed it. I'm starting to hook it back up. I wanted to pause and talk about that resistor for a moment. You may be wondering, well, we had a raster on this set. How is that possible with this resistor being fried? Well, let's take a look at what it's used for. It's right here on the schematic. One end goes to the 275, that's the main B plus that powers the set. The other side of it is where the plus 140 volt bus comes from. That's used for a few things in the sound circuits, to bias the video amp, biasing for a noise inverter, and power for part of the IF circuitry. The deflection, the high voltage, comes off the main B plus 275. That's where we were able to get a raster, but this would not have gotten proper reception. We would not have gotten an image or sound on the screen. Now, why did it fry? I suspect it's because this cap shorted out. So even though this had new caps, at least it sure appeared like the multi-suction electrolytic can here had been opened up and restuffed. Like I was saying, I don't know what caps were put inside of it. I suspect one of them shorted out. Because after I removed it and checked resistance from the plus 140 to ground, it's fine. It's several kilo ohms. I still have that cap. We can open it up. We can investigate. But that's another reason why I wanted to go ahead and replace all these parts. Is something stressed something out, something fried. I don't want to use any stressed out parts. So, anyways. Now you might be wondering, hey, it's a plus 140 volt bus. Why did they spec a 350 volt cap? Two possibilities come to mind. One, when you go to order a multi-section cap, and they still are available from a few places today, unless you want to order one custom, you got to pick one off the shelf. And so they may have just gone with one that they got a good deal on that had a 350 volt section. Another possibility, though, which seems more likely to me, is the power supply for B plus is solid state. The instant you turn this set on, you've got your voltage here. The tubes need some time to warm up, so there's a no load. So you're going to have full 275 here, maybe a little more. And if there's nothing drawing current on the plus 140 volt bus, there's going to be very little current going through this resistor, and this cap is going to go up to about 275. So you'd want to definitely have a cap there rated for well over 140. I want one that's rated for 300 plus volts. I think I'd put a 350 in there, just like the original had spec'd out. Alright, so in terms of wiring this back in, it's going pretty well. A big part of that is because I have a reference chassis nearby. And the more you work on these, the more you get familiar with it. And you may think, oh, it's a whole bunch of wires. How do I know what goes where? They're not all the same. For example, the audio, it's 3 wires inside of an insulating sleeve, and those go right here. Some of these other wires, they're different colors. Some are red, some are orange, this one's blue. Take care of all those first. Or this one here is brown, because that reduces, I should say, the more you do, the fewer that are left to do, and the confusion diminishes. And also just the lead length. I mean, obviously the ones that are long enough to go over here are going to reattach somewhere over here. The ones that are short and go in this area, they're all going to hook up in this area. So divide and conquer is what I'm getting at. Okay, so how have I been reattaching the wires that are in this typical condition where it's been unwrapped, it's stretched out? Well, I already know if I try straightening this out and rewrapping it, it's going to crack off, break off at some point, so I'm just going to cut off about 2/3 of it. That's plenty left to work with. Double check, I'm pretty sure this orange wire goes to audio B plus. Yes, it does, and this blue wire goes up to this lug. So we're making pretty good progress. This corner is just about done. I'm going to unwrap this a little more and then put it down over the post and simply wrap it back around with needle nose pliers. That's it. And then I'll touch it up with a soldering iron. Not a big deal. I'll do the same thing on this one. Back some of it. Open it up. If it was to break off here, there's enough slack on these wires, I would just simply strip more off. Down on the post and wrap it around. And then I'll get my soldering iron out and just touch these up a little bit. When you do that, you want to heat up the stake, not just the wire. You want to get the solder to flow onto the stake. But even if I didn't, there's enough on there. It's making good enough contact. We're not pumping amps through these wires. That would work just fine.